All right, friends. Good morning, good afternoon, good evening, depending on where in the world you are. Welcome to this month's webinar. We're proudly presenting a more expanded version of our webinar on display this month. My clicker's not working for some reason, so let me just do that really quick. There we go. We're going to be approaching some advanced features and some tips and tricks with you about display. We do realize that there are people that may not have been using display in a long time, and we may have some more basic users with us as well. So we'll also be covering some basic concepts, but we'll be expanding on some features and some concepts behind display that we don't traditionally talk about. So hang tight. This is going to be a somewhat eventful presentation. My name is Joe Lima. I'm a product support engineer with Martin Audio. Like the rest of the team, I work a lot in system designs, product support, as the name implies, ease models, education, all that sort of fun stuff. And today, this is what's on the menu. We'll be starting by, or we're going to start talking about a few concepts behind display, how to start and configure the software, how the workflow works, and again, a few tips and tricks on what you can do with it, how and what to export at the end and what to do with it, and then some final thoughts. So just a very basic recap at the beginning, just to tell you what display is in case you don't know. Display is the software, the optimization and prediction software that we use that's proprietary for MLA, wavefront precision, and O-line. It is a patented approach that uses a computer model, so lots of intense algorithms of the array for numerical optimization to help us define the best possible cabinet angles, DSP coefficients to tune our system to meet our objectives. We do that with a very straightforward workflow, starting with venue design, following a few logical steps, all the way through to the optimization output. And then we can upload those DSP coefficients to the system, whether it's the DX processors, or in the case of DX4, or icon amplifiers, MLA cabinets, whatever it is the system that we're using. So the very first concept, just to recap on the workflow and how display works, we come to display, and display is a tool, it's a very powerful tool, and we come to it with just a couple of things. We have our venue data, we have our measurements, our dimensions, our limitations, all of those things, and our objectives, meaning where our audience is, where our audience isn't, if there's anything that we need to avoid in front of the PA, behind the PA, what our SPL target is, our SPL variation. So we come full of ideas to the software, and the software is going to do a lot of calculations for us. So this is how it begins. We choose our array type and size. And by the way, we can go back and forth between any of these steps if we are unsure of the results. Meaning, for instance, the very first thing you do, you choose your array type and box count, but this may be a venue that may fall in between two products, and you're not sure if the right product will be, say, WPS or WPC. You can do two models, or you can just go back and forth and change as you please. So after we choose our array type and our box count, we start by drawing our venue slice. So we grab that venue data that we spoke about above, draw a little slice of the venue, get all our dimensions correct, and proceed on to defining our criteria. So where our audience is, isn't, our target SPL, our variation, all that fun stuff. From then on, the software will start working for us. The first step in optimization is mechanical. It will run through the algorithms a few calculations, we'll talk about that in a second, to get us the best possible angle combination and aim angle combination for our array. So we'll optimize it mechanically. Then we will retrieve that information, make sure that everything is compliant with safety standards, that everything is looking good. We can now take a little screenshot of this, send it to our setup crew, to our riggers, get them flying the PA, while at the same time, we can grab the computer and proceed on to the DSP optimization. It's going to calculate all the FIR filters, everything, all the magic that happens under the hood of these systems. And at the end, we can export a few things. We can export the optimized array preset in the form of a D2P file. That stands for display to preset. And that's exactly what's going to go via ViewNet, the counterpart software, onto the icon amplifiers, MLA cabinets, etc. We can export our mechanical data in the form of an HTML file, readable in any smartphone if needed. Ease data in the form of an XGLC file, which can then be combined onto a GLL within ease. Quick note, this is for full ease, cannot be used with ease focus, but we can use that for 3D modeling. And speaking of 3D modeling, for visualization, for those of you that use a 3D software such as Vectorworks or AutoCAD or something in the likes of that, you can export a DXF wireframe of the array. So if you're showing a customer what their staging is going to look like, you can have a full 2-scale model of the PA with the correct angles, dimensions, and so on. So let's now talk about a couple of core concepts behind display and how this works. There's a lot of people that still are not entirely familiar with how display works. And the first concept we need to talk about is boundary element method. This is, in fact, the computer model behind display. So boundary element method takes in consideration, in a nutshell, takes in consideration driver interactions between adjacent cabinets. So what we're looking at on the screen right now is actually a 6-box array where the second box from the top is turned on and we're measuring it. And we're just measuring the direct radiation from that specific driver. No other driver interactions are considered. What we've done more than a decade ago, or some very intelligent people did over a decade ago, they studied and were able to model the driver interactions between that specific drive unit and the ones in adjacent cabinets. So if you look at the second diagram that I just put there, you can see that now all driver interactions are being considered. You can see how that driver is affecting the other ones next to it and how those are now back affecting this one as well. If you look at just the driver that is turned on, you can see the difference in calculation. So what was determined is that without BEM, the results that were being predicted in the model versus what was being actually measured was up to 8 dBs inaccurate across the spectrum. If you look with BEM, we can get as accurate as a mere 1 dB difference. And that is why this software works so great. That's why the results are almost identical if we go on the field and measure from what was predicted. So how do we apply it? Let's talk about numerical optimization for a second. This is the use of that computer model, the use of that algorithm to help us determine the best both mechanical component and DSP component for our array. It says that it quickly calculates the best solution. Sometimes it's not as quick, we know that, but there are a few million or billion or trillion combinations sometimes possible. I have a little number here that I'd like to share with you. For instance, just at the most basic, which is the mechanical configuration, you take a 16-box array of MLA with 8 possible angles in between each box, spares some paragraphs here. The total number of possible combinations of angles between those 16 cabinets, and we're talking about just 16, is 35 trillion, 184 billion, 372 million, 88,832 possible angle combinations. So unless you're Russell Crowe or Gary Kasparov, I wouldn't really try to beat the computer here. I would just trust it that it's going to do the best for us. The next concept to talk about is the on-axis optimization. So when we're drawing our 2D slice of the venue, we have to be the best judges of what we're drawing into display. What I'm trying to say with this is, for instance, if you take that WPS as an example, it's a 100-degree white box. You may have things that are not on axis with the PA that you may want to still draw, and you may have things that are on axis with the PA that you may not want to draw because they may just not represent a wide enough surface that you may want to sacrifice. So for example, this is very common. You get a vertical slice, a section cut of an installation, for an installation of, say, a church or a performance venue that has a circular balcony. Imagine that that's what you're looking at on the screen. You deploy your PA, and from looking at the screen, it looks like the PA is completely dead spot on axis with the center of the venue, but it may not be. It may be facing outwards a little bit because the venue fans out. So it is not uncommon for us to receive display files that were built based on a section cut of a building, and then we're not taking into consideration that the PA rotated. So now the back wall is actually a bit farther away from the array. The stage edge is a bit farther away from the array. Everything is a bit farther away. So if you're trying to apply hard avoid, say to the balcony face, it may not work as well. That has happened, and that is a common mistake. You may want to go and verify that you take that measurement on axis. On the other end of the spectrum, say for instance that you're designing a system for a festival or an open air concert, something like that. Say the PA is not directly on the stage, say it's off to a side on a wing or a line array structure or something like that, but you still want to apply hard avoid to the stage. You have nothing to apply hard avoid to in front of you, just open air, but you do want the stage to be quiet. Though the stage is not directly on axis with the PA, it will still be within the coverage range behind it. So you may still want to draw it and hard avoid it. You can take that example from the screen right now. Nothing says that PA is exactly on the stage. It may be off stage left or off stage right. However, we do want to hard avoid the stage, and we're applying the hard avoid right now. A couple of things about the slice. We will be talking about this, or I'll be saying this a couple of times during this presentation, just because I see it way too often where users forget to start drawing the slice anti-clockwise, and point number one must always be at the bottom left of the screen, so that the source is always, or the array is always facing the right and the audience is always facing left. Another concept to knock off the park right now is that the colors we're seeing on the screen, that green area is where our audience is, that red area is where the audience isn't. Blue is our proprietary hard avoid, and purple are surfaces that the array cannot hit directly. So those are surfaces that will never be in direct coverage of that array. Another concept, quickly to touch base on, for the ones that are not familiar with it, is our index plot. Whoever's familiar with SMART and whoever's familiar with a spectrograph, this is a little modified version of a spectrograph, whereas the horizontal axis displays frequency, but the vertical axis, instead of time, it displays distance. So what we're looking at on the left and on the right is the same. It's the index plot for the same venue, unoptimized or optimized. And as we move further onto the top, we are moving farther in distance. We will see in a second. The white dashed line represents the beginning of your audience position, so the audience start. The solid white line farther up represents the audience finish. The black dotted line or dashed line is our reference position. And those solid purple regions are those purple regions that we saw a second ago that the array doesn't cover directly. So we can see it here, that region all the way at the bottom of the index plot represents the stage, and that little bit of offstage area before the audience region begins. And then we have from the beginning of the audience region until our reference point, that little yellow triangle there. Then we have our back section and our ceiling. All right, so I always spoke a little bit about concepts. Let's take a look at how we start display and a few preferences that we can adjust. So we all know that display is password protected. For anyone that uses it often knows that it's often password protected. The password that we usually disclose is unlockd2. That's the one you get if you watch the little video when you download the software from the website. However, there is a second password that will automatically unlock the software in expert mode. That's expertd2, which is the one we'll be using today. And there it is. That's what display looks like. If you're unfamiliar with the most recent versions of display, that's 2.3.3. It's the most current one. And that's what it looks like once you first open it. It starts with an empty dashboard, which will unfold once we add an array. Let's quickly take a look at those 4 tabs on the left. So the first one is File, pretty self-explanatory. After you use it for a while, you'll get an extra button for recent projects. The Add tab, just self-explanatory as well. It allows you to add an array, whether MLA, wavefront, precision, or O-line. The Export tab allows you to export all those files that we spoke about a second ago. So the printable HTML report that will contain mechanical information, a few more things as well. We'll see that at the end. The 3D DXF wireframe, the D2P settings file that will actually go to the array, and the XGLC and CLF files to be used with these. And an often overlooked tab, which is the Help tab, actually contains some very cool information here. So the little question mark button opens the user guide. This will basically load the most recent revised version of the user guide on our server. So you need an internet connection for this, but it will just take you directly onto the most recent manual. The little information balloon opens the About window, and you can access some release notes, some cool reference material. There's some white papers there by Ambrose and Jason and everything that is behind optimization arrays. So there's some really fun reads there. And lastly, you have the preferences window. So let's take a look at a few preferences really quickly. Just going to highlight, most of these are self-explanatory. So I'm just going to highlight a few that are often overlooked as well, and they're very helpful. So these are divided in categories. You have general applies to everything that is within display. SPL view applies just to the SPL section. So the slice, so the display tool, and so on and so on. One important thing is that everything that you do here will affect the application. So it will be retained for the next time that you open display. If you make any changes here, just because you want to visualize something different within this specific file, display doesn't know if that's just your user preference. So next time you open display, if you see something funny down the line, probably come back here and correct that. Let's take a look at just a couple that I'm going to highlight here for you. In general, everything is pretty much self-explanatory. I'm going to touch base on show rig warnings. That enables or disables the rig mechanical warnings. So once you get to the rigging tab, it will not, and I repeat, it will not disable the load safety warnings. All those BGVC1 and DIN safety warnings at the bottom right are there for a reason. Those pertain to the mechanical interactions of the actual array, and those cannot be disabled. What this enables or disables is the mechanical warnings. which are the red fail on top of the array. If you're trying to achieve an angle that you can't achieve with, say, you're using an install bar instead of a touring bar, that sort of stuff. And the reason why we can disable this is because quite often these arrays are put in arenas or sports centers or whatever, and people are using custom rigging solutions from, there's a myriad of companies making custom rigging solutions for this type of application, so I'm not going to name any. But for that reason, the design may include an angle that is not achievable with our rigging brackets or frames, but it's something that you can achieve with one of those solutions. So you can just turn that off, because the last thing you want is to get a printable report that says fail to show a customer and have to explain, no, this is just fails because we're doing a custom solution. So you can disable that there. In the SPL view tab, dB per division, it just changes the scale on how you see at the end, whether you want to see a 5 dB or 10 dB variation in each division. I'm going to talk about enable multiplot first. So let's talk about multiplot. Multiplot enables multiple plots to be displayed in the frequency response. So when you look at the SPL view and you have just the average and the reference point there, and everything else is movable, now you can have multiple at different locations at the venue or off the venue. So if you want to just print that so you can see how the system is behaving with distance, you can just enable multiplot, and then you can just choose the number of audience plots to be displayed. Show extreme will show the very beginning and the very end of coverage, dead on right there. Pardon me. Fixed response will toggle. Once you enable multiplot, you can only have one of those, so you can toggle whether you want to show the average or the reference responses. And then lastly, normalize. It's something that's been introduced in display a couple of versions ago. We came to realize that it's nice to be able to measure and compare results. So when we're looking at the SPL view, I like and I tend to have normalize turned on, so I can see a flat frequency response, so I can see the actual variations with distance. However, nobody really wants, we all know that that's a relative flat. Nobody really wants to listen to a flat PA, why would you? And so you can just uncheck normalize, and you will have the factory voicing for that specific system applied to that response, and you can see the curve there. So then you can go onto the field and spend some time doing measurements and compare. It's always fun stuff. The slice and the EQ tool, there's only a couple of things I'm going to touch base on here. Those auto use display and EQ on both. It just basically auto applies the calculated angles and optimizations to the array. So if you're just experimenting, you may want to uncheck that so that you only apply it once. Then you have the system levels. Those are the default target levels for all those. All lines target levels 90, MLA mini, WPM 95, WPC MLA compact 105, WPL MLA 110. This is obviously an older version of display, doesn't have WPS there yet, but if you want to take a wild guess, exactly, you are absolutely right. I can hear you all saying 100. Lastly, in the export preferences, clip D2P file name, it just basically ensures that you are exporting a file with the name that matches the MAT file for display. So they all go together, just for organization. So let's take a look at what happens when we open a project. We have a really cool sample project here for you today. And that's what happens. Once you open a project or create a new project, the 6 buttons unfold on the dashboard. I know most of you are familiar with them, so I'm just going to very quickly touch base on them. We start, as I mentioned earlier on one of the first slides, we start by drawing our slice. Then we go on to defining our criteria. We go on to optimize the array mechanically. Then we can retrieve that information, confirm, make sure everything is okay and good. And then we proceed onto our numerical optimization and then just get our SPL report. And once we confirm that everything is good, we go back onto the export tab and we start getting files out of the software. Cool things about this dashboard is that you can have multiple tabs open. In this instance, this is for the exact same venue. We have 3 different slices with 3 different arrays. That's our main array, that's our outfill, and that's a delay. We'll see with the venue in just a second. You can also rename an array there, and you can delete an array by just naming it delete. And if you knew this information before this presentation, come see me at the next trade show whenever that happens, because I did not know this until very recently. I will admit that. And that is good to know. Sometimes we end up with 25 different tabs of the same venue just because we've been experimenting. All right, so let's take a look at the workflow and how this thing actually works. So we'll be covering all of those things that we said a second ago, and we'll start with slice. So that's what the slice editor looks like in this venue. So rather than trying to create something with the presentation, we chose to just go with an existing design. And it's better for us to just explain why and how these things are there. So the first thing is a slice diagram, and it's a section cut of the venue. It's what we're talking about earlier. It's got the array, which, as I mentioned already, and we'll mention again, is always facing right, with the audience always facing left. It must be drawn counterclockwise from the bottom left of the screen. You see point number 1, it's the bottom leftmost point on the screen. No questions asked there, that's just how the algorithm works. Quite often we get phone calls, emails saying, hey, I got a display file that doesn't really work. I'm getting some really weird results. Okay, can you email it to me? And we go and open, and point number 1 is, well, not there, somewhere else. It obviously also shows the loudspeaker array. It shows the span of the audience region. Next thing we have is our points coordinates section. That has the X and the Z points, where X is the distance from the back wall and Z is height relative to the ground. Now, there's been a change in display a few versions ago, but it's worth mentioning that this used to be relative to the surface underneath, but it is relative to the ground, just because it's easier to copy those measurements from a section cut of a venue than trying to calculate what the surface underneath is. X and Z change the distance and angle if we enable survey mode, which we'll look at in a second. And there's a really cool trick here, is that when we design, most people already do this, but if you're not familiar with that yet, you will now. You don't have to be 100% spot on accurate when you're placing your points on the slice editor. You can just do a rough design of the venue as long as you have the correct number of points you're going to use. And then you can just enter that data manually in these boxes. And you can just enter a number, hit tab, and that will take you right to the next tab. Enter the number, hit tab, enter the number, hit tab, and so on and so on and so on, making the process a lot faster. So the array position is the same thing. We can just place the array anywhere we want within the slice editor, and just go and choose our trim height and our distance from the back wall. If we select on ground, that will, and it's grayed out there because the flown PA would have to be a stacked PA. But if we select on ground, or if we check that box on ground, it will just place the array on the surface immediately underneath, which brings us to the first pro tip. If you are ground stacking the array on top of subs, you should add the subs as a surface, so that when you hit on ground, the arrays will be placed directly on top of those subs. Another pro tip number 2 is, if you are doing all of that on the stage, you can add a point right behind the array, so that if you're hard avoiding the stage, you hard avoid until you reach behind the array, and not have the array sitting on a hard avoid surface, because that will mess the algorithm. Next, we have survey mode, and as soon as we checked it, look at how everything changed. So what is survey mode? Survey mode allows you to grab one of those lasers that goes on a tripod. I don't know many that do. I know the Leicas do. Those are the ones that we use. There's a little adapter that will put it on top of a tripod stand, and you can set a place on the stage, for example, and just point and shoot. And you will get, from those lasers, you will get exactly distance to the laser and angle. And with that, you can draw an entire venue. Notice how the point's coordinates now change to distance and angle, so you can just enter that data there. The vertical offset is just the height from the laser to the surface underneath. And the yellow diamond on the stage, that's exactly the point where our tripod stand with the laser is. I tried out of fun. This exact venue that you're looking at exists. It's a rather large auditorium here in the United States. And I tried with a customer representative that was with me, whereas I went on and measured every single point manually, which took me about a couple of hours. That is really a large venue. He was sitting on stage very comfortably with his laser doing the same thing in about a third of the time. And we were off by 1 inch here, a couple of inches there. So it's very accurate, and it's a very easy and simple way of getting a shell done. So shell control is shell control. That's how you start designing it. You can move vertices, insert and delete. A pro tip, remember to always design it counterclockwise. I don't think I've mentioned that before. In the view section, it just allows you to adjust the way you're viewing this shell. So you can extend the view horizontally or vertically if you need to. Or once you're done, you can just fit it to drawing area so it looks nice and tidy like it's looking on the screen right now. Equal scales will no longer put the drawing to scale. So if you have a venue that is particularly long, but it's not tall, like this one, you can uncheck that, and that will kind of explode. It'll kind of expand it on the vertical axis. So you can see a little bit more in detail. Obviously, it won't be the scale anymore. Same thing, show coordinates in a venue that is populated with a lot of points all the way in the back in the balconies like this one. It may be easy sometimes to identify surfaces if you just hide the numbers. That's what that does. The array section will allow you to add an array, add an audience region, move the start and stop, or delete it entirely. It's a pro tip. The audience region will determine the start and stop, which are the nearest and farthest limits of coverage. This is there so we can get familiar with the term start and stop because it will be used farther along in software. Let's take a look at cover. And this is where we're going to define our audience coverage, our non-audience areas, the SPL at reference point, the variance or the dB relative to that reference point. See what that's all about. So first things first, there's going to be a few sections that are hidden. That's for a cleaner UI. We don't always have to go, and make changes. We're just using in basic mode. We may just leave those collapsed, but we can expand them by just hitting those little triangles. And that's what happens. We now have access to a few more sections. Let's take a look at them. 4 sections in the screen. The first one is audience offsets. This will just basically set the audience ear height. So we considered that a standing person has got their ears on average at 1.6 meters high. For the US market, that's 5 foot 3 inches. And if you're sitting down, then you're at 1.2 meters or 3 feet 11. However, say you're standing or sitting on a high top. You may want to go, or sitting directly on the floor, who knows? You may want to go and do a custom height. That's entirely possible. A loud ether will consider variable ear heights, especially in the near field, where the PA usually breaks more. And there's another button on top that says uniform offset, and this will adjust the entire audience region at once. So if we check uniform offset, that little section will change and will look like the one that just unfolded. where you select everything at once. If it is not uniform, say for instance, your main audience is standing, but your balcony is seating, just like with line properties, we'll see that in a second. Once you select standing or seating your custom and you apply that property to a line, make sure that you click in between the white dots on the actual shell and not on the virtual reference microphones. That's just because that's how the software is programmed to work. So let's talk about line properties. Line properties will apply the different properties to the shell surfaces, basically. So not audience will be the target that we define minus 20 dB, and that is our red dotted line on the screen. Our audience is our green dotted line, and our proprietary hard avoid, which will extend an extra 10 dB in reduction, is our blue dotted line over there. In this case, it's the stage. There's an extra color there, which is purple, which indicates surfaces outside of the array's direct coverage, as I mentioned before. And again, when you apply changes to a line property, just make sure you click on the shell lines, not the virtual microphone dots. The target profile moves the reference point, and you can select your reference SPL. As we saw in preferences, in this case, we're talking about MLA compact. Our reference SPL is 105. If for any reason you do want to change that, you can change it there. However, default is 105. And you can also define your SPL variance. Your start delta, which is what variance you want at the start of coverage compared to your reference point. Your stop delta, the same thing in the other end of the coverage area. The reference point can be moved in two ways. You either click on move reference and then just drag and draw, or drag and click to select the position you want it to, or just enter coordinates. And here's what you can do with the SPL profile. So in this case, you can see the default SPL variance for wavefront precision systems, which is +4 -4. That means that if I define 100 at the reference point, I'm looking at 104 beginning of start of audience and -4 96 at the end. But we can get creative and do things like this: a shape profile where I'm only raising it 2 at the beginning, but I'm decaying 6 at the end. So we can defy and alter the inverse square law using our optimization. We can go to the extreme of doing something like that, +5 -8. But there are limitations to this tool. Obviously, if we're trying to cover 100 meters or 300 feet, roughly 328 feet to be more accurate, of audience with a WPS array of 10 boxes with a ±2 dB profile, what's going to happen is we're going to get a pretty much flat array that is really not aiming down because we're really trying to go for distance there. If we simply change that from ±2 to ±4, we get a much better coverage from the array, a much better curvature, and we will also get SPL, because if we can really only achieve 86, for instance, at the furthest distance, and we are going with ±2, then we're hard limiting our system at 90 dB in the front row, whereas we have a ton more horsepower than that. However, if that is enough for what you're doing and you're really trying to go for consistency, then go ahead. Just understand that you will have that limitation. If this is a rock and roll concert, you may really want to go and change that to some ±5, for instance, so that you can get a little bit louder in the front and allow the array for a much more natural decay. So now we spoke about that, let's talk about target refinement. Here we introduce our atmospheric conditions at the software. That's temperature, humidity, air pressure, and we can adjust the amount of air absorption compensation that is taken into effect for high frequencies. Why is this important? Because we all know that with distance, at least temperature and humidity will have a key role in how high frequencies are dispersed. We'll take a look at that right now. The top target coverage diagram will show absolutely no air absorption compensation being taken into consideration. And you can see at the end, at the high end of the spectrum, the color starting to get a little bit darker there. You're going to get a bit of a dull PA at distance because, we're not tuning the PA for that. When we do introduce air absorption compensation, you can see that on the bottom one, we get a much flatter response. So once we do get all of our criteria in, we're going to go and let the software start producing ideas for us. I like to think of display as a tool, and as with all tools, we have to know and learn how to interpret results. And there's nothing that says that we can't keep going back and forth. Quite often, I keep going back and forth into the cover tab just to change that SPL profile. I may not like ±1. I may go back and do ±2, or the other way around if I see that I have a little bit of room to improve. So the first step in optimization is our splay tab. We're going to optimize our array mechanically. This is what it looks like. The first thing we look at is our cabinet angles. It displays, obviously, all display angles. We can manually adjust them using that drop-down arrow if we really want to. Now, keep in mind that it went through literally trillions of calculations to get you these results. So you may want to try to win. I don't think you will, but I wish you good luck. And you can always reset it by hitting the reset button at the bottom. Next thing up is the array diagram. It just shows a visual representation of the array. It includes the height, the distance from the back wall, the aim, and all that stuff. Note that the array height is always measured from the top of the array. So from the top of the topmost cabinet in the array, not from the top of the bumper, not from the top of the subs if you have subs flown immediately above. It's always from the top of the topmost cabinet. So if you have to plan on for, rigging hardware or subs or whatever, you have to take that in consideration. On the other side of this window, we have our current acoustic output at the bottom. It just displays an index plot, and you can see it before and after it's been optimized. You can see the difference in consistency and the results. At the top, you have the coverage window, which just shows the array position, the on-axis box aim, and the approximate coverage limits, top and bottom. Worth noting that while you optimize, this window will change to another index plot, and which will update in real time, showing all the different variations with different mechanical configurations. What you can control on the right, which is pretty straightforward, aim, height, and distance from back wall for the array. That aim is automatically determined by the optimization. It will automatically populate it there, though you can change it if you need to or if you want to. And you can also change the number of boxes. For instance, if you're not sure, in that application that we just looked at a second ago, that 10 WPS will do 328 feet, and you want to increase that to 16, 18, or 20, you can do that just here. The next window, which is the optimization, it allows you to do a little ratio of priority between target and leakage. So how much more is one thing important to the other? It's a ratio, so this is 1:1. If you change it to 2:1, I can think of an open air festival with absolutely no restrictions in terms of noise pollution, maybe changing that 2:1 in favor of target. The other way around, if you're in a festival that has grumpy neighbors nearby, or that sort of situation, you may want to change that to 1:2 in favor of leakage. But that only affects the mechanical optimization, so that's directly tied to how the array is deployed physically, not the DSP. That is a different story at the end. Allow polish will let the optimization run a second pass just to refine those angles. And then maximum time just sets the maximum time that it will allow for the optimization. If you're doing an array of 20 MLAs in a very complex venue, that may actually take a long time. So if you're in a hurry, you may want to limit that. Otherwise, the standard is 600 seconds or 5 minutes. So once you're done setting up your angles, we open the rig tab just to confirm that everything looks good and it's safe and secure to rig. First thing up is our diagram, which again shows bottom and top height. It also shows you the topmost height of the bumper in this one and the center of gravity. All fun things and very important things for riggers. The cabinet angles again shows you the optimized splay angles in between cabinets. The detail diagram shows you the detailed view of the venue, including the aim of the top and bottom cabinets, on axis aim, that is not topmost and bottommost. And then you have mounting options, which vary depending on which PA, which system you're using. But you can do a few things here. You can choose the mounting type, whether you're flown, stack, if you're undecided which one's going to work best in the venue. Pole mount if applicable, if you're using WPM or MLA Mini, for example. For those PAs and touring frames that have positions, rear and front positions, that can be changed here as well. The number of rigging points, if you're using one motor or two, you can still change and adjust the array position here. And obviously these options will vary according to the specific product being used. Same thing with aiming and loading. You will get the design aim, so the top angle. I will also get the bottom angle in case you want to slap a second inclinometer at the bottom of the array. I know people that do it just to be sure that the coverage is spot on. You can do that, and this will tell you what number you should be reading there. You can correct the design aim. If you switch from 2 points to a single point, you may not be able to reach the design aim that was intended. So you can just click that use nearest button, and that will just correct the aim to the new one, and will tell you the nearest hole where you can achieve that angle. And it will show you the total mass front and rear load if you're using 2 points, as well as the status of your BGVC1 and DIN safety standards. Lastly, if you are using MLA Mini and WPM, which have a transition grid from their companion subs, if you're flying the array underneath them, it will tell you the transition grid design angle that you should have set in that transition grid, which is 0, 2.5, and 5, if memory doesn't fail me right now, in this case 5. And then we move on to the EQ tab. EQ tab is where the magic of DSP happens. It looks kind of like this when you first open it. And let's take a look at what you can do with it. So in the calculation section, again, you can input or update your environmental conditions. The reason why you have it in 2 points is because the other one is a general calculation for both mechanical and numerical. However, if you fly PA in the morning and you have 45% humidity, and then at 6 p.m. it's doors and it's 85% humidity, you may want to just come here and have a place to change it right before you re-optimize for the new conditions, without having to switch back and forth between tabs. You can also adjust the optimization bandwidth and the display resolution, and you can set your goals. So basically, these are percentages of importance for non-audience, audience, and hard avoid, or leakage, target, and hard avoid. By default, leakage minus 20 dB, target allows for a 0.5 dB variation of that 105 that we just set for MLA compact. And hard avoid goes as low as 30 dB below. The default is 33% importance for each. In the case of this venue, we really went, because we were trying to achieve plus or minus 1 dB, we really went high on an importance for target. but also hard to avoid because there is a lectern directly underneath that line array. So we're trying to allocate more resources on those two situations there. If you're using a wavefront precision or O-line array, you'll have one more tab here, which is resolution, because those are systems with scalable resolution. And this is where you can adjust what kind of resolution you're using with your PA. All right, and this is what we see from the EQ tab. The index plot updates with optimization, just shows you what's going on. The audience sample responses shows you the traces and relative SPL across the audience area at various microphone positions. And then let's run this and optimize that array really quickly. Nobody has ever done it that fast, I can tell you that. And then at the end, or at the bottom, we have the achievement window that I like to touch base on because it's something also often overlooked. So the achievement window shows the effectiveness of the optimization on the different goals, hard avoid, audience, and not audience, which can be viewed in this case as percentage, but it can go back to preferences and change this to actual values, which shows you the difference then in dBs. And what you have is the spectrum laid out left to right. So 10 square, that's 100 hertz, all the way to 10.4, that's 10K at the right. And you have an achievement percentage. You see the 0 line over there, and whether it's underperforming or overachieving the desired SPL variation. And this is just informative, right? This is a tool that will show you what your optimization is doing and how do I explain this? This will show you how you can effectively achieve the goals that you propose to. So in this instance, I can tell you right now that hard avoid and non-audience can easily be achieved in this venue with all the goals that I'm proposed to, but perhaps +1, -1 dB may a little bit of a stretch for MLA compact on a 280-foot long venue that is that complex with only 12 boxes. So I may want to relax those objectives. I may want to add more boxes to help me achieve my objectives. So it's a signal that if you do have room to make changes, you will get better results. Okay, and that leads us to our SPL tab. The SPL tab looks exactly like this. The frequency response graph, I'm gonna let this video roll for the folks that have not seen this magic before. As you move your cursor up on that index plot, you will get the different EQ plots in the frequency response window for the position you're in. By default, you have the average and the reference right there. One is white, the other one is yellow. Average is just of the audience response, so from start to stop. And reference is dead on at the reference point. And the response at the cursor position, when you look at it in the frequency response graph, it will change color depending whether you're in an audience, non-audience, or hard avoid regions. And you have a little white asterisk at the left in the venue plot that will move as you move the cursor just to indicate which position in the room you're in. The video was too fast. I'm just gonna go back and I'm gonna replay it again. And you can see as the cursor moves, that asterisk on the left is moving and the frequency response window is displaying different plots for the regions we are hovering over. All right, the tools to the left affect just the frequency response graph. So this is not going to affect the optimization. It just lets you see things differently. So if you're targeting specific problems, you may change your upper and lower frequency. So you just want to look at between 800 and 4K. You're looking for intelligibility. You want to just look at that, nothing else. You can change that there. You can change the frequency resolution and the space resolution. So add or remove the space resolution will add or remove reference microphones from the venue. The frequency resolution will just ease or reveal more detail in that frequency response. As you can see right now, sorry, I didn't know this was going to do this, a new slide. If you look at the frequency response now, that is with the standard of 2 in frequency response and space response. Going forward, that now changed to 3 and 4, and now you can see just 16K and 400 hertz. So you can see just a more limited bandwidth, less microphones, and more frequency resolution. So it's just targeting that area over there. You can also change atmospheric conditions, but this will not apply to the optimization. It's just the way you're seeing it. So if you want to take a look at, if you're in the morning, and again, it's 45% humidity, you want to take a look at what the PA is going to respond like in a few hours time and the humidity is 85%, or is it really going to make that much difference? Let me enter it here, and you can see the predicted difference. That nonlinear audience checkbox in the bottom left, it just changes to a more linear deployment of microphone positions, which is pretty useful if the far field is closer to the front row, so if it's a smaller venue. Otherwise, by default, you will have more microphone positions in the near field and less in the long or in the far field. Also, you can see there the normalized button next to the done button, or normalized checkbox next to the done button. That will apply or remove the voicing for that PA from those plots. And here's multiplot. So this is what I was talking about in the beginning, in the Preferences tab. You can enable multiplot, and this will show you multiple plots for different regions of the venue. The number of plots can be selected from the Preferences menu, sorry, went too far. And you can also select or choose to permanently see the extremes, so the beginning and the end of coverage. So let's take a quick look at the Export tab. Here's what the rigging report looks like. It contains not just rigging information, it contains a few other things, like temperature, humidity, what target SPL are going for, what variation are going for, what software version this file was created in, etc., etc. And you can access it from the printer icon, and this will shoot out an HTML file, which can then be, readable in any browser, whether it's a laptop or a tablet or even a cell phone, probably even Apple Watches nowadays, who knows. Another thing you can export is a 3D DXF array. So this you can then import to AutoCAD, Vectorworks, probably even SketchUp nowadays, and this will give you a visual to-scale model of this array. Here's a little video showing how to export the ViewNet. The one thing to note here is that this is a two-step process. So once you select your folder, even though Windows by default displays that button as save, you're really only selecting the folder you're saving to, and you have to go and click export, and now you have the file right there. If you had more than one array, where you have that example one selected in that vertical window, you would have all of your arrays there, and you could select to export one or more or all of them onto the same D2P file. That way, once you're opening it in ViewNet, it just makes it faster and easier to load different presets. And lastly, this is how you export to Ease if you're using Ease 4. Again, not for use in Ease Focus. You just do the same thing. You select the folder you're exporting to and you hit export. And again, you choose which array you're exporting. And then there's a whole webinar on Ease that shows how to import those files. And now here's some final thoughts. Display is a tool, like I said, for the creation of optimized venue-specific presets. So if you're moving from venue to venue, if you're not doing an installation, if you're a rental company, if you're a production company, Remember to re-optimize every time you go to a new environment. You can import pre-designed shells to give you a good head start if you're going back to the same venue in the future. But it is venue specific. So if you're going to different venues, you should always make different optimizations. The same way I mentioned before, I mentioned a couple times the example of a festival where you have different humidities. Festival could be anything else, but different humidities in the morning and in the afternoon. You can create different presets for that and quickly load them to the PA. But again, there's a whole webinar on ViewNet on how to do that. It is limited to the accuracy of user input. That's fairly obvious, nonetheless should be stated. If we are inputting wrong measurements, if we are inputting wrong data into the software, the results are not going to be accurate because, you know, they're as accurate as your data. The optimization is automated. The data input allows you to have creative control. The SPL profile being a good example of that. It was important to denote the limitations that it has. However, it is also important to denote the creative control it gives you if you want to create, if you have different or one-of-a-kind challenges ahead of you. I can think of an application that I was supporting a few years ago where it was a big student party with a DJ stage, big line array, and they really only wanted to cover the first 100 feet on a 400-foot long venue. But the thing is that from 100 to 150 feet, it was an F&B area. So we really went to the extreme with with that SPL profile before we applied non-audience and hard avoid because there was no need for that. So it gives you a lot of creative control in those type of situations. Also worth noting that for nearly all purposes, if you are in a traditional venue, if you are doing a traditional no big obstacles kind of deployment, basic UI mode should get you through. However, we do hope that today's expanded concepts will give you a little bit more knowledge to overcome weird situations whenever they arise. And remember, like I mentioned before, all options that you select in the Preferences tab will stay there. Will stay there until they changed again.